Hello, let's continue our Sudoku adventure with Charger by Palfly Kampling. So this is an ambiguity puzzle. So it's up to the solver, us, to determine what the clues mean from some restrictions. So let's go over what that specifically is. So we do have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these circles that are connected by lines. Let's start with a simple example here. They are either double arrows or between lines, and it's up to us on a per line basis to determine which is which. So for example, this could be a double arrow, and if it was, that would mean that the sum of the two digits in the circle is equal to the sum of all the digits on the line. So if this was, for example, 1, 5, that would add to 6, and this would also add to 6, we could do 2, 4. So that would work as a double arrow. Now if it was a between line, then what that means is that whatever digits end up in the two circles, the digits in the line are strictly in between the two. So if this was 2 and 6, then these two digits would have to be between 2 and 6. They'd have to be from 3, 4, 5 only. So we could do like 4, 5, we could do 3, 5, 3, 4, just as long as they're in between the 2 and 6. We can't do a 1, we can't repeat the 2 or the 6. All right, and we don't know which is which, so it's up to us to determine. Also, you should consider these to be overlapping clues, and so just because this shares a circle with this does not mean they have to be the same type. So this could be a between line, and then this could be a double arrow, just as an example. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so I'm thinking this is pretty limited if it were a double arrow. In fact, it could be a double arrow, because this could be 1, 2, 3. This could be 1, 2, 3. That in total adds to 12, and we could just put 6 on both ends. So double arrow is still on the table for this guy. Between line is definitely possible. Okay. This could be a double arrow. Let's see. I'm thinking about if this is 1, 2, 3, then this is also 1, 2, 3. And so if it was a between line, we could be 1, 3 with a 2. If it was a double arrow, we could be 1 plus 2 is 3. Yeah, that works just fine. But let's think about this. If this was 1, 2, 3, this would be 1, 2, 3. This would be 4, 5, 6 and 4, 5, 6. What kind of line would this be? It certainly wouldn't be a between line because we cannot make that. Even a 4, 6 would force all of these to be 5. So we would have to be double arrow. And this would add to way too much. If this was 4, 5 and 4, 5, that would add to 18, and these could only add to 12 max. So even though 1, 2, 3 works here for this line, it forces 4, 5, 6 here and 4, 5, 6 here, and that does not work for this line. Can't be between line, can't be double arrow. So we are not 1, 2, 3, which means this is not a double arrow, because that was the only way this was going to work. 1, 2, 3 here and 1, 2, 3 here with double 6. So that's not what it is. So I'm going to use green to represent that this is definitely a between line. And so we have at least 3 unique digits that are inside of this range. So for example, if it was 2, 3, 4, this could be a 1, 5 pair. And if it was like 3, 4, 5, this could be a 2, 6 pair. So we're from 1, 2, 5, 6. Okay. So there are no 1s here and no 1s here, no 6s either. So we know that there's a 1 and a 6 here, and there's a 1 and a 6 here. Interesting. Which means there's also a 1 and a 6 down here, and also a 1 and a 6 up here. I bet we have to think about that. I was kind of hoping for some easier stuff to get started with, but I think probably this line's next. So I'm trying to get a vibe on like whether I think between line or double arrow is more restrictive here. Maybe double arrow. So I need a, or actually no, it's literally the between line. Yeah, okay. Sorry, this is much more obvious than I thought it was going to be. We need a 1 and a 6 up here, but they can't both go in this circle, which means one of these digits here on the line is a 1 or a 6, and you can never put a 1 or a 6 on a between line, which is why they ended up there in the first place. So this actually, I'm going to use purple and say that this is a double arrow. So purple will be double arrow, which means that the sum of these two is the sum of all these. Now, so the total sum needs to be even. That's something we can use. Oh no, the total sum will be even because this plus this is always even. Never mind. But why is the total sum even? I mean, I think that's a good property of double arrow, because the sum of these two is equal to the sum of these two. If we double a number, it's essentially adding all of these together is doubling whatever that sum is, because we're adding it to itself, and that's always going to be even because we're doubling it. Okay, so 1 and 6 are up here and down here. Let's think about whether this can be a 1-6 pair with a 1-6 pair, because that would be 14. No, that doesn't work. These can't add to 14. They add to 12 max. So one of these is definitely 6. That's a conclusion, because if we have a 6 here and a 6 here, that already adds to 12. That's no good. Can a 6 do these both have to be 6? Is kind of my next question. Or can they both be 6? Adding to 12. So we know that that would force the 1 onto here and here. So that would add to 2. So then we need 2 digits that add to 2. We need to be 1-5 pairs, because we need 10 without 6. So we double 5. So one of the options is this is 6, and these are 1-5 pairs. I wonder if that's the only option. So can a 6 be on here somewhere? No, both of them can't be. So this 6, okay, so that's one way to think about it, is if there's a 6 on this line, for example, and then we can't put a 6 on this line then, because, well, we just talked about it would be too big of a sum. So this would be 6. And then the consequence of that would be that these 3 digits would add to whatever goes in here. So yeah, if it couldn't be a 6, this couldn't be 6. So we'd have 2 digits that are the same. We know we'd have 2 digits that are 1, actually, potentially. So that would be 2. And then we could do with a 3. So yeah, I guess what I'm saying is we could do. No, could we? Well, the roping kind of prevents it. Oh my gosh, there's something with the roping that I'm not thinking about. I can add one more digit that's going to get doubled up here and here. And if these are not the same digit, this plus this I think that's the key, right? I think these have to be the same digit. So let me explain why. Let's use colors to explain why. If this is green and this is not the same digit, then we're going to put green, say, here. It doesn't really matter the ordering. I'm just going to go left to right. Now these greens cancel out, right? They cancel out in terms of the sum of these needs to total the sum of these two, and this contributes the same sum as this. So now what we said is that these 3 would add to this one. So this is going to be purple, though, which is not green, right? And purple by roping is forced onto here. And since purple by roping is forced onto here, it's going to cancel out that purple. And so we've already reached green plus purple, and we have these 2 digits still to add in. So in conclusion, these are the same digit as each other, and these are the same digits. And so they certainly aren't both 1. They certainly aren't both 2. So the question to ask is, can they both be 5? Well, no. So if they were anything but both 6, we'd be enforcing 2 6s onto here, and that's broken. That's the obvious way to do it. So these are definitely both 6. And then now what we said is, because one of these is a 1 and one of these is a 1, that adds to 2. We need a 5 in order to get to 10. So we're going to get to 12. I mean, 5 plus 5 is 10, plus another 1 plus 1. So this is forced. And I don't know. I mean, it felt like it was the only way to do it when I thought of it, but I feel like that was kind of an interesting way to prove it. 2, 3, 4, and 2, 3, 4. I'm sure there are probably easier ways to prove that. But so this is the high digit on our between line, so this has to be the low digit. We can't put a 5 or a 6 here. And so now 6 has actually been limited to be exactly here. This being 1 or 2 makes a whole lot of sense, except there's a 2 on here, so it has to be the 1. It gives us the 5 and the 1 here. Very nice. So these are just between 1 and 6. So Sudoku just will take care of that. So do we think about this one then? If it's a between line, we could do 2, 4 with a 3 in the middle. Can it be a double arrow? Double arrow would have these two add to this one. 2 plus 3 is 5 already. Yeah, that doesn't work. So this is definitely a between line. This is a 3 surrounded by a 2, 4 pair, and we can mark it green as a between line. All right. Makes sense. Okay, so what is next? A drink of water, maybe. that was a lot. I finally found a good way to think about it. I'm pretty proud of that. All right. Now we have this 1 and 6 up here. This cannot be a 6. And there's a 6 on here. So this could easily be a 1, 6 pair adding to 7, and then we could just make these two add to 7, and either as a 2, 5 or a 3, 4, and that would work just fine. So this could definitely be a double arrow. Between line also seems to be... Between line doesn't work, because there's a 6 on this line. Right. So this is a double arrow. It doesn't have to add to 7. I was just showing that there was a possibility for it to be a double arrow, which is good, because clearly not a between line with a 6 on here. What is kind of the... I think I want to pencil these, because that's on this line here. In fact, there is a 6 on this line. Okay. I think that's what we need to know. There's a... but let's do the whole triple. So the 6 is down here. We need a 2 and a 4. So this can't be a between line, because there's a 6 on the line. So this is a double arrow. There's a 6 on this double arrow. I think 4, 6 doesn't work. Adding to 10, these can't be double 5, and that would be... 4, 6 is the only way to add to 10 if you can't repeat digits. So this is not going to be 4, 6. This is going to be 2, 6, adding to 8, giving us the 4 here. And so if that adds to 8, this has to be 3, 5, the only other way to add to 8, and that leaves behind the 1, 4. That's our 4, and that's our 1. Yes, the 2 and the 4. All right. This is a triple. Let's just write it out. 2, 3, 5. That's not a 2. All right. What's our next step? One up here. Well, this isn't a double arrow, because it would be 6 plus something is this. So this has been a between line since I wrote a 6 in there. I just didn't spend time thinking about that. So this is basically a thermo. We just have to get larger because it's a between line. So if a 3-cell between line, you can think of as a thermo. You just don't know the direction, but we do because that's a 6. So you could mark this as 2, 3, 4, and then this would be 3, 4, 5, but not a 4. That makes a 3, 5 pair here. So 1, 2, 6 is what's left. That's not a 6. What do I do now? It's got to be this line then. It's the only one I haven't thought about. Or I haven't thought about the double arrow much. I know there's a 6 on here. So if there's a 6 on here, can I use the 1 here? No, it doesn't seem possible. Right? We know there's a 6 on this line. If I put the 1 here, then 6 plus something equals 1 plus something. 6 plus a non-1 equals 1 plus a non-6. That's nonsense, right? There's no way that math is going to math. So this has to be the 1, 6 pair, meaning this does add to 7. So as I said, this is 2, 5 or 3, 4. 2, 5 seems to be pretty open. 3, 4, this 4 tells us this would be 3, this would be 4. Well, this is never a 2. Because between line, there'd be nothing in between. And then double arrow, this would only add to 4 max. Actually, yeah, and without a 1, we can't have this add to 4, right? Almost worked, but no. So this is never a 2. If this is never a 2, this is never a 5. Because these add to 8, if you remember. Or 7, sorry, 7. So this is the other way to add to 7. This is also 2, 5, or 3, 4. I'm wondering... If this added to 7, this would be 5, 2. And this would be a 3. That would add to 8. That doesn't work. So here's what I'm talking about. I guess we're talking about if this was a double arrow. We know these add to 7. That's kind of the point. No matter what, these two add to 7, because this adds to 7 and this adds to 7, that leaves 7 left. We don't know how it adds to 7, but it does add to 7. So, as a result, if this were a double arrow, these would need to add to 7 as well. The only way we're adding to 7 with these two digits is 5 plus 2. But the problem with 5 plus 2 is this also needs to add to 7. Right, so no matter what, we can't have both this and this add to 7. And that's what would have to happen. I think that's the clean way to look at it. Therefore, this is a between line. And if it's a between line, these are between 1 and 5, which is, we already knew, well, I guess they're not 5. So 5 in this box has to go here, which does make that a 2, which makes that a 1. We get our 3, we get our 1 and 5. Wow, that was intricate. All right, 6 and 1. That's not 2, that's not 5. This is a 5, giving us 3, 2, and 5. That's our 3. That's not a 3, that's not a 1. All right. These two digits are a 3, 4. This column needs a 5. I think we're finishing up. What's left? 2, 4, 6 here? What did I miss? Oh, this has to be a thermo, remember? This has to be the 2. It can't be the 4 because of the between line logic. That's 6, that's 4, that's 6, that's 2. That's a 3 and a 4, that's a 3, 2, and 4, and we're done. All right, interesting puzzle, Palfly. That was mind-bending in several points. But yeah, I think the two really big things were realizing that because of the roping, these two digits had to be the same digit. Just, they had to be. And then that forced them to be 6. Very, very interesting. And I think that's just generally true of any double arrow that's roped like this. And then the second thing was, we knew these two added to 7 and these two added to 7. So these couldn't both be double arrow, because if they were, then these two would add to 5 and these two would add to 5, making these two the same digit. All right, cool. I enjoyed that. Hope you did too. If you did, then why not leave a like, subscribe, and a kind comment below.